Going on now to topic 4 of chapter 5. Remember, chapter 5 deals with polynomials and polynomial functions. And here in section 4, we're interested in trinomials. That is, there are going to be 3 terms of the type x squared plus bx plus c. Now, as we mentioned in class, this is sometimes referred to as the standard form of the quadratic expression, where we sometimes put the letter a x squared, the a standing for the coefficient of x squared, plus b, which is the coefficient of x, and then sometimes in this position there's just a constant. So this is called the standard form of the quadratic expression. Now, if we add an equal sign to it and a 0, it now becomes the standard form of the quadratic equation, because we've added the equal sign and equal to 0. And then later you'll see how this all fits in. Well, in this section we're going to be dealing with factoring trinomials, and then equations containing trinomials. That refers to this. And going back to what we had in the previous lesson, zeros and factoring. That is sort of like finding the zeros. All right, we're going to start off with doing the matching, and we'll follow our usual procedure in that we'll pause, and you can pause, and then I'll go over these with you. This will be a good review of what we've been doing. For instance, a polynomial with 3 terms is a trinomial. Tri is the prefix for 3. A polynomial with 2 terms is a binomial. Again, the prefix for 2. Now, when we get a trinomial, sometimes it cannot be factored. Those that cannot be factored are said to be prime. Again, the first step in factoring is put it in usually standard form, but then check to see if there's a common factor that can be taken out of each term. We've been working on that a little bit already. And as I mentioned just a few moments ago, this last term in standard form is considered the constant term. Remember, it's ax plus bx plus c. C would be the constant term. Now, here's a trinomial. And we might say, well, where did that trinomial come from? Well, it came from multiplying these 2 specific binomials through probably the FOIL, and we get this trinomial. But when we start with the trinomial and we're said to factor it, we go this way. Remember, the FOIL brings it this way. Factoring brings it this way. So if this is the trinomial, these are the factorization of that trinomial. And that's what we're going to be working on as we go through the next few examples. So as I mentioned in class, what we want to do is develop a procedure for factoring these trinomials. And the procedure would be first to check to see if in fact it is in standard form. Okay? And this is. Now, is there any common factor? No. Then your next step and we like you to do this vertically if you can, is to put 2 sets of parentheses underneath it. Usually it won't have to be this big, but I'm doing this for better observation. Now, when we did the FOIL, the first thing we did was to multiply this by this. This is where the first is. So this by this to get that. Well, what are the possible factors of this, of that, to get this and this? And the answer is an x. So keep in mind you are on your way. You have put it in standard form. You have checked to see that there's no common factor. And you've put 2 sets of parentheses. Now, this is what we call a protocol, a modus operandi, a strategy for factoring. And by doing that every time, you will master this skill. Okay, now we're going to do it out of order a little bit. We're going to look at the last term. Now, for the last term, we multiplied this by this. These are the last spots. And we got an 18. And we had to remember that later we added we multiplied the inners and outers and got this middle term. So here's where we think a little bit and we say, okay, what are the factors of 18? And you might start to list them. 1 times 18. 2 times 9. And you might say 3 times 6. And then they go the other way too, but this will be enough. Because what I'm looking for is factors that give me, when I multiply an 18, but when I add them up, give me an 11. So I look over here. If I add these up, I'm going to get a 19. If I add these up, I'm going to get an 11, and that's what I'm looking for. Okay. So I'm going to put here 2 and 9. So when I multiply them, I get an 18. And when I do my outers and my inners, it adds up to an 11. And then I'm going to look carefully at the signs. Well, this is positive, so all my signs are going to be positive. And then now what do I do? Well, I check just by FOIL that this is correct. And it does check. All right, as we go on to example 8. Is it in standard form? Yes. Is there any common factor? No. Next step, 2 sets of parentheses. Now, what are we going to put in our first position? What times what gives me t squared? Well, t times t. Now, what can I put as factors of 40? Well, again, I could do this mentally. 1 times 40. 2 times 20. 4 times 10. 5 times 8. Now as I did this mentally, I saw that it adds up to 13. So I'm going to try these. 5 times 8. Now, 5 times 8 makes 40. But now when I go to do my outers and my inners, I'm going to get a 13. But notice I need a negative 13. So this has to be a positive. This has to be a negative. Now the only way that will happen is if this sign is negative and this sign is negative. because the multiplication of two negatives give me a positive, but when I add them up, it gives me a negative 13t as my middle term. So this one checks. So notice again the strategy. Standard form, no common factor, two sets of parentheses, looking what will I put in my first position. Then I look at my last position. What are the factors? I list mentally, you'll be doing this, and then which set would give me my middle term. And then I watch the signs and I check it. So that this doesn't run too long, I'm not going to go over the steps every time, but we see here that, is there a common factor? Yes. So I'm going to pull out that x, and I get x squared minus 4x minus 12. So I put my x there, and I'm going to put now two sets of parentheses. Just going to work on this. So an x there, an x there, factors of 12 that somehow give me a 4. Well, I went mentally, I'm going to put a 6 there and a 2 there because I know the difference of a 2 and a 6 is a 4. And notice that my third term here is negative. So in order for that to happen, one must be negative, one must be positive. So this one is a negative 4. So I'm going to put the negative by the 6, a positive by the 2. And again, I'm still in a trial guessing period, although I'm pretty confident about this one. And when I FOIL it, it checks out. So this is a positive 2, a negative 6, gives us our negative 4x, and this gives us a negative 12. All right, looking at number 10. Again, since standard form, I see I can factor out a 5. And I get n squared plus 5n minus 14. And we still need the 5. Two sets of parentheses, an n and an n. Now as I see 14, I see 7 times 2 because the difference of that is going to be 5. So I need a positive for a middle term. So of my factors down here, I'm going to pick the larger number as positive. Now remember, before you click enter, you could still change your answers, and you need to FOIL as a check. So this gives me my n squared. This gives me my negative 14. I get a negative 2n, positive 7. This checks. Now, for number 11, we're going to use the technique, is this in standard form? No. So first thing you have to do is put it in standard form. So once again we ask, is this in standard form? Yes. Can I factor out a common factor? There's not one. What do I do next? Two sets of parentheses. What do I put in my first spot? Well, A and A. Now again, mentally you're thinking of factors of this, and what jumps to mind right away is 4 times 11. And 4 and 11 add up to 15, so I'm on the right road here. This is going to be an 11, this is going to be a 4. Now, notice that this sign is positive, while this sign is negative. So in order to do that, I have to have both negative signs here. That will, when I do my FOIL, will add up to a negative 15a. But when I do my last, will give me the product of a positive 44. And this checks. Now, to save time, I thought I might, get some of these worked out. But again, I want you to see the process and watch the thinking of it. So is this in standard form? Yes. 2 sets of parentheses. Now we know that t is going to go there. And now we're looking for factors of 11 that will add up to 8. Well, since 11 is prime, there's only one set of factors. And there's no way I can get an 8 out of that. So number 12, after you tried or looked at it, is prime. This is not factorable. Okay, so here again, is it in standard form? No, put it in standard form. Any common factor? No. 2 sets of parentheses. X, X. Now, here you might wonder, what are the possible factors there? Well, again, you might have 1 times 36, 2 times 18, 3 times 12. Oh, I think I got it right there. Now notice, I had to do that. I didn't know this right away. So a 12 and a 3. And some might ask, could you put the 12 there and the 3 there? Absolutely. And this is straightforward since they're all positive. And I FOIL that and it checks out. Now, here's a case where there's a negative n squared. So what I'm going to do is I'm going to put it in standard form, but I'm going to factor out a negative 10. Oh, my daughter who's here called me and I got distracted. So I'm going to factor out a negative from this and also put it in standard form. So this then becomes a positive n squared. This becomes a positive n. And this becomes a negative 42. Now, notice what I've done. I had a trinomial. I see that my n squared was negative, so I factored a negative 1 out of each of these. That reversed the sign. So where this was negative, it's now positive. This was negative, it's now positive. This was positive, it's now negative. And that negative sign up there is critical. So I keep my negative sign. There's no more common factors. So I put my 2 sets of parentheses. Now, an n goes there, an n goes there. Well, that's not too good looking an n, but we'll leave it for now. Anyway, 42, one of my favorite numbers. 6 times 7, and we have a difference of 1. So I'll put the 7 there and the 6 there. Now notice my middle term is a 1n, a positive. So I look at what factors are the larger factor. I'm going to use that sign, because if this is a positive and this is a negative, when I go to add them up, for my middle term, I end up with a positive n, positive 1n. And it foils and it checks out. Now again, all the answers for these are in the back of the chapter, but I want you to see the process. So once again, standard form. Any common factor? No. So two sets of parentheses, x, x. Factors of 18 that have a difference of 3 will be 6 times 3. This is where your multiplication table really comes in. Now my middle term is a positive, so my larger factor needs to be the positive. I FOIL it and it checks out. This one gets a little more challenging here. So it's in standard form, and as you note, you probably imagine that you could take out 12z, and you can. So 12z leads me with z squared minus, this would be a 2z, and this is minus 15. Okay, you can just check your work to be sure you've done it right. 12z out of each term, yep. I've got the right signs. That looks good. Okay, so the 12z stays. And now two sets of parentheses. So z and z. And I have a 15, and I'm looking for something that has a difference of 2. So how about a 5 and a 3? My middle term is negative, so the larger of these factors would be negative, and this one would be positive. And I FOIL it, and it checks. Now here's a new twist here. We have a squared, and that's sort of the lead, and it's diminishing. But then as we go the other way, ascending, we have the b squares, the powers of b. Very good. So let's put two sets of parentheses there. No common factor. So here I know I'm going to have an a and an a. And as a thumbs up for this last term, you know you're going to have a b there and a b there. Now I haven't really looked at the numbers. I'm just looking at the mechanics of this. So it's in standard form. I put two sets of parentheses. I put an a and an a and a b and a b. Now I'm going to look at my 22. Well, 2 times 11 is 22, and it has the difference of 9. Now keep in mind, I had a lot of experience with this, and I like factoring. It's a little bit of a challenge, and it's a puzzle in a way, and you want to try to master it. But again, knowing your times tables really help. So one term's going to be an 11 here, the other one's going to be a 2. And notice your middle term is negative, so the larger of these factors has to be negative. The other one will be positive. And if we FOIL this, it checks out. Now, again, I'm trying to show you pretty much every one. Is it in standard form? Yes. Is there a common factor? Yes. I can take out y to the third from each term. That leaves me with y to the second minus 74y plus 73. And I can see right away this is going to be 71 times 3. I'm sorry, 73 times 1 will add up to this. So let's just do it. And if my mouse works correctly, I see somebody's at our door too. Well, there's plenty of family up there to take care of that business. Y, 73 and 1. I need a positive, so both of these need to be negative, and inners and outers add up to that. Last, do that. Let's see here. Well, we're having a busy morning. I guess the family left, so I had to answer the door. And we're continuing. So we had mentioned earlier in a previous lesson that A times B equals 0 indicates that either the factor A or the factor B, if they were 0, then the product of this is 0. This is called the principle of zero product. Now, you might be wondering, where is all this factoring getting to? Well, there's a trinomial that, when it's factored, becomes this. Now, I had said earlier that if we have a trinomial, this was a standard form of the quadratic expression up to here. If we added a 0 to it and equal signs, we then got the standard form of the quadratic equation. And we know then that this, if we equal it to 0, this is a factor, this is a factor, and if we take each of these factors and set it up as we did previously, we can then solve it for x and say x is 1 or x is 9. We have solved this quadratic equation by factoring. And that's where we're going with the factoring. So this is factored for us, and we're saying now convert it to an equation, equal the factors to 0, and you can almost pick them out, because here t will be 5. Just reverse the signs as you transpose it. T equals a -7. And it's just that easy. But notice we came through all these steps. Now, we're going to tie this into a number of previous lessons. There is a quadratic equation in standard form. If we factor this, and that is, say, y equals this, we put this in our calculator, this is what it looks like. Now, suppose we said, find the zeros. Well, we're looking for when y is a 0, which is right there and right there. So if we made our little t-chart like we had done, remember there's 2 zeros here, so our x here would be a -1, and our x here would be a +4. We are finding the zeros. Now, keep in mind that here y is going to be a 0. And that's what we have. So let's factor this now. X, 4, 1. And our middle sign is negative, so this is a negative and this is a positive. And that will equal 0. Now when we solve it, this x is going to be a -1, and this x is going to be a +4. A -1 and a +4. So you're actually seeing the visualization of this parabola in finding the zeros. And that's what it's all about. So anytime we solve a quadratic equation, we are, in the sense, finding the zeros. I'm going to cut this down a little bit so we can make this tape a little shorter. Again, if they're giving you the graph, factoring this, we could see the parabola. This is going to be a 1, and this is 1, 2, 3, 4. Oh, I did that incorrectly, didn't I? I didn't count it right. Oh, wait a minute. 1, 2, 3. No, that was right. Ooh. From here it's 4, but from 0 it's 5. All right. So there are the zeros. X is 1, X is 5. If we factored that, that's what we would have gotten. So now they're getting into it. Find the zeros. So y is 0. It's standard form of the quadratic equation. We factor it. We equal each of the factors to 0. X is -3. X is an 8. Okay, this one, again, we're finding the zeros. So this will be a 0. Is there a common factor? Yes, I factored it out. Got this. And then I factored these. Now, notice we have 3 factors. And this equation is to the 3rd degree. There's going to be 3 answers. So this one will equal 0. So this x is 0. This will equal 0. So when we transpose, this becomes a -2. This will equal 0. When we transpose, becomes a positive 15. And we separate our answers in MATLAB by putting commas. Again, we have found the zeros. And repeating, when there are 3, the exponent is to the 3rd power, there are 3 answers. So a few more ideas on strategy. Is this in standard form? No. Put it in standard form, equal to 0. Factor it. Check it by FOIL. What will this x be? Opposite sign, a 2. This one, opposite sign, an 8. Is this in standard form? Yes. Take out the common factor? Yes. Factor it. And since this is to the 3rd degree, we're going to have 3 answers. N equals 0. So this one is 0. Here, n minus 2 equals 0, opposite sign, a 2. And here, a -3. Sometimes they want you to put it in order. You'd have the -3 first, but I don't believe our book makes that distinction. Okay, there are lots of examples. Again, all of the methods that we've talked about. Put it in standard form. Bring that over, equal it to 0. Factor out the greatest common factor. Equal each factor to 0. So a is 0. This is transposed, becomes a 12. Here, you want to have your x squared positive. So I'm transposing that so it equals 0. It's now in standard form. Factor it. Take each factor, equal it to 0. So here, x is 2. Here, x will be a -25. Now in this one, again, they're showing you the graph. We want to find the zeros. So here, it's going to be a -24. And here, it's going to be a +16. If you were to graph that, that's what it would look like. That's what we're doing. And it would factor into those. Going up a little bit. Here, the same thing. Find the zeros. So x is a 34. X is a 47. We are finding the zeros. Now here, these are the answers. They want us to write a polynomial function that has these. Well, notice here we're doing the reverse. So these are our answers. So we'll put 2 sets of parentheses. We'll put the opposite signs because that's how it's started, going backwards. Then we FOIL this, and there's our trinomial, and it's equal to 0 and its function. So theoretically, this should be on this side. So this one, the very same way. We know that x is 0, so there's this x. 2 parentheses, xx, opposite signs of 2, -2, opposite sign of 7, -7, and then multiply this by FOIL, get this, then distribute the x, and there's your last answer. Okay, it's just a little bit over 35 minutes, but I think there's lots of stuff. And in some cases, you may want to watch the video more than once.